Good day, everyone. So for today, we will be discussing handout number 4, which is all about chemical reactions. No, so here we will be balancing chemical equations. Also, in this handout, we will be learning how to predict the products of different chemical reactions. Also included in handout number 4 is the stoichiometry. No. The determination of the amounts of reactants and the amount of products, as well as the limiting reactants and the theoretical and percent yield. So let's define first what is a chemical reaction. So the process by which the atoms of one or more substances are rearranged to form different substances is called a chemical reaction. A chemical reaction is another name for a chemical change. No, so to represent the chemical reaction, we have this chemical equation. So in a chemical reaction, the substances that react are called the reactants or sometimes reagents, and the substances that are produced because of that reaction is called product. So we use formulas to represent the substances involved in a reaction when we write a chemical equation. So in an equation, the formulas for reactants are placed on the left side of the arrow, and those for products are placed on the right side. So either substance may be written first on each side of the equation. So a balanced equation shows the relative number of atoms of each of the elements involved. So an equation must have equal numbers of atoms of each element on each side para ma-consider siya nga balance equations. Yeah, again, the number of atoms of each element on both sides should be equal, okay, for us to consider that chemical equation balance. So we have here coefficients. So these are numbers that are written before the formulas, and it tells us the relative numbers of formula units of reactants and products involved in a reaction and balance the number of atoms of each element involved. So the coefficients in a balanced equation give the ratio of moles of each substance in the reaction to moles of any other substance. So they also give the ratio of formula units of each substance to formula units of any other substance. Say for example, in the reaction of hydrogen and oxygen, this will yield water. Okay? So para ma-balance ni siya, we will write 2 here. Here, 2. Okay? So kini nga mga numbers, class, before the chemical formula is called the coefficients of the chemical equation. So it means nga 2 moles of hydrogen and 1 mole of oxygen will yield 2 moles of water. So kung ingani galing class nga wala may coefficient nga makita before the chemical formula, it simply means nga 1 na siya. No? So na siya 1 ani, so there is no need to write. Okay? Nga na. So take note that there are 7 elements that occur as diatomic molecules, or molecules with 2 atoms when they are not combined with other elements. These are hydrogen, oxygen, nitrogen, fluorine, iodine, bromine, and chlorine, and should be written as H2O2, N2, F2I2, Br2, and Cl2 respectively. So in writing, kung kanang sila ra ba kanang during the chemical kanang reaction, in writing the chemical equation, dapat since diatomic molecules man siya, so dapat na ay subscript nga 2, no? So that is why if babantayan ninyo in writing the chemical formula for the reaction of hydrogen and oxygen to form water, ang imong hydrogen and imong oxygen na ay subscript nga 2 because those elements occur as diatomic molecules. So dali na siya timan-an kanang naay mga gen og INE ang ending, those are diatomic molecules. So let's now proceed with balancing equations. So the first step in writing a complete and balanced equation for a chemical reaction is to write correct formulas for the reactants and products. Then we use coefficients to change the number of formula units to get the same number of atoms of each element on the two sides of the equation. So this is what I have said no sa last na to nga meeting, na it is really important na we know how to write the correct chemical formula for a substance, no? Kay ining balancing na to, if ang ato ang chemical formula nga gisuwat is wrong, then the chemical equation nga ato ang ma-generate or magama will also be wrong. Okay, so that is the first step in writing a balanced chemical equation. Okay, so to illustrate, let's have example 4.1. Balance the equation for the reaction of barium hydroxide and hydrobromic acid to give barium bromide and water. So first, we will write the chemical formulas, no? So for the barium hydroxide, no? Barium hydroxide, you have barium positive 2 sa hydroxide negative 1. So magbaylo, so you have BaOH2. So kini. Then hydrobromic acid, no? So hydrobromic. So gikan na siya sa combination of hydrogen and bromide ion, which is negative 1. Okay, so magana you have HBr. So this one to give barium bromide. So barium positive 2, bromide, negative 1. So, magbaylo, BaBr2. No? So, this one. And water. So, again, dapat ka mauta mo interpret sa gihatag na problem. So in this case, our barium hydroxide and hydrobromic acid are our reactants, and the product of the reaction is the barium bromide and water. So if imo siyang i-evaluate, di ba ningon siya nga ma-consider na nato na the equation is balanced if the number of atoms of the element on the reactant side is equal to the number of atoms of that element on the product side, no? So looking at this, no, makaingon ta dili pa man ni siya equal nga naman. Isa nga clue nimo, for example, for bromine on the reactant side 1, no, diri sa imong product nga side is 2. So ang ato ang buhaton is we will balance the equation. So evaluate the chemical equation and place a 1 before the most complicated formula. In balancing equation, the class, there is no definite step on what to do, but there are tips given for us to be able to balance the equation more easily. Okay? So ang isang tip niyang gihatag is you start with the most complicated or most complex formula. In this case, no, our most complex formula is the barium hydroxide. So we will write 1. Then ang barium here is 1. Dapat pila maibutang ani para mabalance ang barium? 1 sad. Okay? So mana ni siya. Then observe that there are 2 oxygen on the reactant side, no? Nganong 2? The subscript here will be distributed inside the parentheses, no? So 2 nga oxygen. If you will be looking at the product side, 1 ra ang ato ang oxygen, no? So ang ato ang buhaton, we will write 2 here. So mao na ni siya. Then ang hydrogen, no? Ang hydrogen on the reactant side on the reactant side 2 sad, no, kay ma-distribute man ni siya inside 2 plus 1 3. Here ang ato ang reactant on the product side, ang ato ang number of hydrogen on the product side is 4, no, kay 2 times 2 4, so dili balance. So para ma-balance, we will write 2 here, no, kay para 2 hydrogen plus 2 hydrogen 4, 2 times 2 4. Okay, then for the bromine, no, 2 times bromine 2, so 2 sad ni. So the equation is now balanced, no. It will take 1 mole of barium hydroxide to react with 2 moles of hydrobromic acid to produce 1 mole of barium bromide and 2 moles of water. So we will check now if the chemical equation is now balanced. Barium on the reactant side 1, oxygen 2, no, ma-distribute man eh. Hydrogen 4, so 2 plus 2 4, and bromine is 2. Ma-distribute sa na siya, ana. On the product side, barium 1, oxygen, ma-distribute, so 2, hydrogen, 2 times 2, 4, then bromine is 2. So now the chemical equation is balanced, no? Delete any coefficients equal to 1. So the final balanced chemical equation is this one. Again, if ang imong galing coefficient is 1, there is no need to write that coefficient. Okay, it is understood nga na anay 1 diha. So we have this one. This is our final chemical equation that is already balanced. Okay, let's have another example. Balance the equation for the reaction of cobalt 2 chloride and chlorine, which produces cobalt 3 chloride. So again, wala pa ta kahibaw, no, kung unsay mga coefficient ana. So we will write with the most complicated, no. We can start with cobalt 2 chloride or cobalt 3, no. Same na sila. So ari ta mag-write una og 1. Okay, so ang cobalt nimo is 1, so you write here 1. Your chlorine is 3. Looking at the reactant ka side, your chlorine is 2 plus pila may imuhang coefficient ani para ma-equal siya nga 3, no? So you write here 1/2 kay 1/2 times 2 equals 1 plus 2 3 equal siya ani, no? Mao na ni siya na 1/2. Then as much as possible dili ta magbutang og coefficient nga kanang in fraction form, no? So we will simply multiply it by 2, no? So this will become 2 moles of cobalt 2 chloride plus 1 mole of chlorine will yield 1 mole of, this is 2 moles of cobalt 3 chloride. Okay, so this is now the final equation. So checking, no, let's check if equal ba gid siya. Cobalt on the reactant side, cobalt 2, here 2. Ang chlorine, 2 times 2, 4 plus 2, 5. Plus 2 di ay 6 di ay, no? 2 times 2, 4 plus 2, 6. 2 times 3, 6. So the equation is now balanced. Then, when any element appears in more than one substance on the same side of the equation, we balance that element last. Again, that is just a suggestion on how to easily solve or how to easily balance a chemical equation. Okay, so let's have example 4.3. Write a balance equation for the following reaction. Potassium iodate plus potassium iodide plus hydrochloric acid will yield iodine, water, and potassium chloride, no? So again, katong gigon ganiya, start with the most complex one. In this case, the potassium iodate, no? So you write here 1. So here imong oxygen is 3. On the reactant side, on the product side, only 1, no? So we will write here 3 kay para ma-equal. Okay, then pagkahuman, we balance the hydrogen. Okay, we balance the hydrogen. Kining nga step class or kining nga process, ang yang gipakita ani nga, ang yang illustrate ani nga tip is this one nga, when any element appears in more than one substance on the same side, we balance that element last. Mao na nga awahin na to i-balance si potassium nga naman kadaghan man siya ni-appear siya sa potassium iodate, ni-appear siya sa potassium iodide, no? So giawahi mo nang start with oxygen, then we proceed with hydrogen. So sa hydrogen, no, if we will look at the product side, you have 3 times 2, 6. Pila man ito yung butang ani para ma-6 po siya, no? So you will write here 6 kay para 6 hydrogen mo na ni siya. Then si chlorine, no, 6 times 1, that is 6. Unya dire pila may atong isuwat ani para mabalance sa chlorine, we also write 6. So mo na ni siya. Okay, then pagkahuman na-balance na to si chlorine, let's balance potassium. Okay, so ang potassium on the product side is 6, no, 6. On the reactant side na naman siya 1, so pila itong ibutang ani 5. Okay, so 5 plus 1, 6, so 5. Then lastly si iodine, no? So 5 man, 5 imong iodine diri plus 1, you have 6, no? So pili mo ibutangan ni, no, na may 2, no? So 6 divided by 2, that is 3. Okay, 3 times 2, 6 man, no? So this is now the balance chemical equation. Again, you do not need to write na the coefficient nga 1. So, this is now your final equation. And if you will check, ang potassium 1 plus 5, 6. Ang iodine 1 plus 5, 6. Ang oxygen 3, no? Ang hydrogen 6, ang chlorine 6. On the product side, 3 times 2, 6 kini. 3 times 2 for hydrogen, 6 kini. 3 times oxygen, kini. 6 times potassium, kini. 6 times chlorine, kini. So the equation is now balanced. Okay, let's continue with this example. Write a balanced equation for the reaction of sodium hydroxide with phosphoric acid to produce sodium monohydrogen phosphate and water. Again, it is very important. Now we know how to write the correct chemical formula that will represent the substances that were being mentioned in the problem. Okay? So for example, we have sodium hydroxide, no? Sodium Na hydroxide OH negative, so that is NaOH, this one. How about phosphoric acid? So IC man siya, so gikan na siya sa phosphate. Okay, so hydrogen positive 1, si phosphate PO4, yung charge is negative 3. So inga na magbaylo, so that is H3PO4. Okay, then sodium monohydrogen phosphate. Okay, so si monohydrogen phosphate, makita nyo na sa inyong periodic table, that is HPO4, iyang charge is negative 2. Unya, ang hydrogen positive, sorry, it's not hydrogen, it's sodium. Okay, sodium positive 1. So magbaylo, mayon ang Na2 HPO4, this one. Then of course water. So now we will balance, no? We will start with the most complex. In this case, ang pinaka complex na sodium monohydrogen ang pinaka complex na formula is the sodium monohydrogen phosphate. So we will write here 1. So since ang imuhang sodium is 2, so mo nang naatay 2 dire kay para imong sodium 2. Then for kanang PO4, no, or kini is PO4 1, no, so we will write here 1. Then sunod for the oxygen, no, oxygen we have 2, no, so we will write here 2 pod niya. 2 times 2, that is 4, no, so equal ra siya kay you have 3 plus 1 hydrogen. So the balanced chemical equation is now this, no? 2 moles of sodium hydroxide plus 1 mole of phosphoric acid will yield 1 mole of sodium monohydrogen phosphate and 2 moles of water. So to make balancing some equations a little bit easier, we can balance any polyatomic ion that maintains its composition through an entire reaction as the entire ion instead of balancing the individual atoms of the elements. So to illustrate the tip nga gihatag niya, let's have example 4.5. Balance the following equation using the polyatomic ions rather than the individual atoms. So dili nimo siya bungkagon, mao ra gid iyang pasabot. So we have here barium nitrate plus sodium carbonate will yield barium carbonate and sodium nitrate. Okay, so ayan pasabot nga dili bungkagon class. Let's start with the most complicated one, in this case kini. So imuhang barium 1, so ari 1, imuhang nitrate is 2. Diri ang imong makita ani is kuan naman 1, no, so butangan mo siya 2, no. Then si carbonate here 1 rasad, no. So si sodium 2, si sodium 2. Okay, so the equation is now balanced, no. 1 barium nitrate, 1 mole of barium nitrate plus 1 mole of sodium carbonate will yield 1 mole of barium carbonate and 2 moles of sodium nitrate. Okay, so that is all for the balancing of chemical equation.